So up to the last class, we have discussed about different type of assignments, assignment statements, print statements, conditional statements, and we started with repetitive statements, that is iteration statement. We kind of concluded with a while loop. Today's agenda will be on for loop, another way of repeating the execution of certain block of code. In the last class, we have shown that a for loop will be considering each of the elements from a sequence data type, and it will be printing, or it will be evaluating, or it will be kind of manipulating on those individual items from that sequence data. Now, by this sequence data, I am referring to lists, tuples, strings, dictionary as well. So these will be discussed later on when we'll be discussing on those collection data types or collection literals that we have just mentioned earlier. So this is the syntax of the for loop. So for, as you can see from the color, is a keyword. Variable is a name of a variable. In is an operator, as we have mentioned earlier during the discussion on operators. This is a membership operator for variable in sequence. Now this sequence is basically a literal which should be a sequence, that is a list, tuple, string, or something similar. In the last class, we have written one code such as this. Here for C is this variable. In, as I have said, is the membership operator, and this is the sequence literal here. Range 110.1, as I have said, range is a predefined program, a predefined function in Python, which takes at most 3 parameters. Start, second is the end, and third is the step. So this will be generating a sequence. Follow my words. This statement, not this statement, this expression. This is not a statement. The thing that I have highlighted here. Range in bracket 1,10,1 in bracket end. This is not a statement. This is an expression. And will be creating one sequence from 1 to 9. That is from 1, taking the steps in 1 up to the value less than 10, that is 9. Now this can be in reverse order as well, like say from 10 to 1 in steps of -1, printing from 10 up to 2. So this is the start, this is the end, and this is the step. So basically it will be, as you can see, it is generating one sequence, and this for loop or this for statement here is actually taking an individual items from this sequence, and it is kind of, in this case, we are just printing the value. Now, just to mention, we'll be writing codes with range here as well, but just to mention, this is also a perfectly fine range function. By default, this and this are perfectly same. So by default, steps are considered as 1. If I do not mention any step, it will be considering step as 1. And the starting will be by default considered as 1. So if I execute, the starting will be considered as 0. Extremely sorry. There is a jumble up between that. So basically, this is same as this, and which is also same, right? As you can see, I am executing every time 7 is the 7th cell that is being executed here. So by default, the start is considered as 0, not 1. Okay. So this will be starting from 1 to 9. But if I do not mention anything, the starting will be considered as 0. Now, those of you with the knowledge of C, C++, or Java, we have written some codes using array, right? Now, arrays are 0 based. So from that point, it is easier to remember. I kind of mixed things up because in Java, in Python, we will be looking at some place which will be starting at 1. But range is a function. Without mentioning the start, it will be considering start as 0. Okay. Now the for loop flowchart, something like this. Some statements which is outside the for loop, then we'll be encountering, say, this for statement. So for each item in the sequence, it will be checking whether the last item is reached or not, or the last item is already considered from the sequence or not. If not, then the body of the for loop, in this case this line, will be executed and the next item will be considered. And it will be checking whether the last item is reached or not. In case of a last item is reached, in this case 9, so this is basically similar to using this range function. Now, in this case, it is a list. Again, list will be discussed in details in later classes, later on in this course. But just for the time being, this is just a list containing 10 values, which is again a sequence. Now, in this sequence, this for loop or this for statement will be considered taking individual items one after the other. First, C will be 0, then 1, up to say 9, the last item in this sequence. Then, if the last item is reached, if it is true, yes, then the statement outside this for loop will be executed. Let's make the code a little bit decorated. Okay. Now, if I execute, you can see this is the line. Let's just enable the line number. This is a line for line before the for loop. So basically this sum statement. Then this is the for statement. It is also checking it. It will be responsible for taking the individual items as well as checking whether we have reached or we have already traversed or considered all the items in this sequence or not. And this is basically the body of the for loop, in this case only one line. And this is the statement after for, which is in this case the 4th line. Now, as you can see, there is a colon here, which I have mentioned is the indication of an indentation. So the statements which will be inside this for body, the body of the for, will be having the same indentation. Like if I want to print different statements, then this is in this case basically the body of for is consisting of 2 statements. First it is printing the value, then it is printing the value high. And that's it. This is just for you, just a toy example. And as you can see, the indentation is same. Now, if I break the indentation rule like this, it will be giving us an error. Unindented error line here. Indentation error, unindent does not match any outer indentation. So it will be expecting either this to be aligned with this, right? Aligned with this or with the outer statement or the indentation of the outer block. Okay. By default, as we have said, there are 4 spaces, 1, 2, 3, 4. But if we want to declare a block, we can also choose a single statement as a single space as well. But remember, to indicate a block, the block should be having the same indentation for all the lines. Okay. So the control flow. So for item in sum sequence, item will take a value, a single value from this sum sequence, and it will be executing all the statements sequentially in this body of for loop. And then this step 1 and step 2 will be continuing execution until all the items in this sum sequence has been considered or has been traversed. As I have said in the last class, traversed means, or traversal means, visiting all the items in a sequence. It is called traversing. Now, if we compare a while loop and a for loop, the flow chart, in a while loop, the body of the while loop is responsible for making this text or test expression or this Boolean expression as false. As we have discussed, this condition remains true, it will be an infinite loop. That is, this body of while will be continuing execution indefinitely. So it is the responsibility of the while of the body of the while loop to make this Boolean expression false in between the execution. It will ensure, in that case only, it will ensure that it will be coming out of this while loop. Otherwise, it will be continuing execution indefinitely. But in case of a for loop, it is basically by the for loop will actually taking care of that. As I have shown you here, I am not actually making the, I am not actually changing anything. But earlier, while in this while loop, as you can see, if I kind of skip this line, if I skipped this line, x will be remaining 0 forever, greater than 0 forever for a positive input, and it will be an infinite loop. So as I said again, body of the while loop to make this Boolean expression as false. Otherwise, it will be an infinite loop. It is not true in case of a for loop. In case of a for loop, it is basically considering the individual items from the sequence data, and it will be automatically coming out of this for loop when all the data are considered or all the data is basically traversed. Any question up to this?
So sir, basically for loop is always fine for the last item,
Right?
And the while loop is sometimes C for the test expression.
Right.
So is it useful to use while loop over the for loop, or which one will be better?
Good question. So the obvious next question that you must be having is when to use while loop and when to use for loop.
Yes, sir.
It is your question, right? Yeah. So this is my next slide. So we generally use a while loop when we actually don't know how many times the statement inside the while loop is needed to be executed. Because a for loop, when you are defining it, you are defining how many times it will be basically executed, the body. Right? So when we are defining a for loop, we are already defining how many times the body of the for loop will be executed. It is not same, it is basically not the same scenario for a while loop, because in while loop there can be a situation based on the input that it will be needed to be executed, say, only twice, and for other input, it might be the case that it will needed to be it will be needed to be executed, say, for 5 times. Now we have already discussed this with a small example. For if I make a bad choice, bad initial guess, as we have discussed earlier, then the statement in the while loop is needed to be executed longer, right? Or more number of times it needed to be they are needed to be executed. In case we make a good guess in the initial case, it will be executing the while loop in a less number of times, right? You get the answer?
Yes, sir.
Okay. So repeated steps. So this we have already discussed. So what will be the output in these two cases? So for this case, it will be printing hello Python indefinitely, and it will not be coming out of this while loop, never. So it will be indefinitely printing this statement hello Python. Why? Because this Boolean expression will be remaining true always. C equals to 10. 10 is 10 greater than 0? Yes, it is greater than 0. So while this Boolean expression is true, this statement will continue execution. As we are not changing this Boolean expression from inside this while body, it will be indefinitely printing this hello Python, and this out of while loop will never get executed. This is exactly similar to this while true printing. So this printing will be getting printed in the screen indefinitely. It will continue printing forever. These are called infinite loops. So an infinite loop is a loop in which case the condition or the Boolean. Now, obvious question you might be having is, what is the utility of an infinite loop? Well, from the initial examples that we have shown here or here, it you may I mean, it might seem like it is not actually useful. They are basically getting created out of errors in our logic. In this case, basically we have forgot mentioning this, I mean, updating the value of C here. But we will be discussing in a couple of minutes why infinite loop will be needed for some cases. Let's write some program on those.
Sir, excuse me.
Yes.
Sir, about while and for loop, usefulness
Mhm.
of while and for loop. For
Mhm.
for steps where steps are real number, we need
Right.
to use while loop, right? And for steps which is integer, we can use for loop.
It is
Like
a very good question. So the question is, in case of the steps are integers, you are asking whether you will be using for loop, and in case it is decimal, whether we will be using while loop. Is it the question that you are asking?
yes, sir.
Okay, then let's look at another example. So let's make another for loop for I in range, say 1.0, ending is say 2.0, and step is say 0.2. Then print I. Then let's try to execute this. You can see the range function is actually considered taking the start and end as integers. Float cannot be actually given as parameters in this range function. So from this example, it seems like we should not be using a for loop in case the steps are decimal, right? It seems like this. Is please respond.
Yes, sir. Yes, sir.
Okay, now coming to the funny part. Let's replace this. So what we, I mean, by this, what we want to do is basically we want to print 1, then 1.2, 1.4, 1.6, 1.8. right? Now, if I replace this, let's see what happens. One, if I now execute this, you can see it is considering the individual items. So I am not actually, so basically I am showing you that this is not the case that for always for loop will be applicable for integer values. In other word, I can kind of make another statement out of your question, which is range. This function will not be taking any floating value. But if we want to do the same thing using some other mechanism, in this case, a list, we can do that. Your answer, the answer to your question is, it is not always true that while loop will be always applicable for decimal values, and for loop will not always be applicable for only for integer values. There are other cases where for while of course you can understand. So we have already written that code. In this case, this is while loop we are applying on integer data, right? So this is always x will always be integers because we are considering the quotient. Here we are considering integers. We are also considering the integers where when we are using the range function. That is the restriction of range function. But to show you some scenario where this decimal values can also be considered for while loop, this is a case where this is basically a list. But from the definition of for loop, as you can see, or definition or use case of for loop, as you can see, used to iterate over a sequence. Now this sequence can be a list of anything. It can also be a list of names as well. Just to show you an example, if I just replace, say, Alice, it is a string, right? We have briefly discussed or briefly mentioned that Alice is a string, capital ALICE. As I have said, well. And now, if I execute this, can someone, say what will be the output? It will be printing ALICE, the individual items in this sequence. Okay. So I'm online, right? Please
Yes, sir.
respond.
Yes, sir.
Okay, okay.
Yes, sir.
So again, coming back to your question, uh, as long as it is a sequence, it can be, for loop can be applied. The main difference of application of for and while will be based on this condition. So in those cases where we will be modifying, where we don't know how many times these set of statements are needed to be executed, in those cases while loop are applicable. But for those, in case we already know how many times it will be executed, how many times the set of statements are needed to be executed, in those cases we will be using for loop. But again, for any kind of sequence data, for loop is applicable. Not only for integer data, floating data is also possible. Just to show you an example, I have shown you with another. The restriction of range is integer. The set, the start, end, and steps should be integers. If you replace them with float, that we have discussed, in those cases, it is actually a violation against the definition of this range function, not the definition of this for loop. As long as this is a sequence, for loop is applicable.
Yes,
The
sir.
question answer is clear, right?
Yes, sir.
Great. Yeah. Any further question?
Sir,
No. Yeah. Please.
in Python, does the for loop supports condition checking? Like in C
Good
or C++,
question. Good
we
question.
had condition
Good
checking.
question. So for in C, C++ or Java, those of you who had the knowledge, we used to write, so for I equals to 0, then semicolon, then say I is less than 10, then semicolon, then say I plus plus, right? In this
Yeah, yeah.
case, there are three fields. This is the start, this is the condition check, and this is the increment or decrement, or the change of value of this iterative variable. In case of Python, this is not actually true. We cannot actually change this condition from inside this for loop. Later on, we can write some codes, some complicated codes, where we can actually change this statement from inside this for loop, but that is not actually the general way of using for loops. So in single word, the answer would be no. We cannot actually make this condition check from inside this for loop. Okay.
Okay, sir.
Okay, so let's write an infinite loop. So as I said, if I execute this, it will be continue the execution. I need to stop the kernel or interrupt the kernel to stop the execution of this code. Now, as I have said, there are applications for which we need this. So I will be discussing some examples in some moments. Now, what if from this infinite loop, I want to break out of this infinite loop at some point? Such as, let's consider, say, let's have c equals to 10, c while c is greater than 0, hello Python. Okay, let's have another statement. Say if c is say greater than say 100. So basically what I want to do is, this is not the best practice, I must mention this, but in case if I want to only print this hello Python for the value of c, say let's also print the value of c here. If I execute, you can see 10, 10, 10, 10 is getting printed. Also, if I make the change, so c plus equals to 1, so the value will be 10, 11, 12, but this will remain true, right? So this will be remaining an infinite loop. So the output will be 10, 11, 12, and it will be continue printing this. Now, what if I want to break this infinite loop when the value of c has become more than 100? Now, again, this is not the best practice. Basically, what we can do is we just need to make this. But what if this condition, I don't know actually what this condition is. For the time being, let's assume that. What if this condition cannot be changed? What if? In those cases, what we need to do is, as I have mentioned earlier, it is the responsibility of the body of the while loop to make this Boolean expression as false. Then only we will be continuing the execution, right? So there are two statements which can be used to specify or to jump from one statement, from the execution of one statement to the other. I'm using the term jump in a metaphorical way. Literally, jump is actually happening, but not in the similar way as we have discussed while discussing about the structured programming scenario, like the spaghetti programming scenario that we have discussed. So those two statements which are there, with those two keywords which are there in Python to control the loop statement or the execution of the loop statements, are called break and continue. So break terminates the loop statements or the execution of the loop statements, and transfer the execution to the statement immediately following the loop. So what we can do is we can simply put a break here. Now if I execute this, you can see 10, 11, you can see the output we are getting up to 100. As soon as the value of C has become 101, as soon as the value of C has become 101, this statement has become true. But in the earlier case, this statement was false. For C equals to 10, is 10 greater than 100? No, false. Is 11 greater than 100? No, false. Is 99 greater than 100? No, false. Then C has become 100. Is 100 greater than 100? No, false. Now after that, the value of C has become 101. Now this statement is remaining true always. Now what I am doing, forcing a break from the execution of the statements. Now the value of C has become 101. Is 101 greater than 100? Yes, true. So this statement will be executed, which is basically a break statement, which will be taking the execution flow from here to the outside of this while loop, which will be causing this out of while loop to be getting printed in the screen. Okay. So the basically the flow of the flow of execution in case we encounter a break is like this. In case of a for loop, it looks like this. For if some Boolean condition is true, then break, then the execution will be coming out of this for loop and the codes outside the for loop will be executed. And this we have already shown with this example, right? So basically, if this condition is true, this break will be taking the flow of execution from here to outside the while loop. Now let's look at another example of a for loop of an example of application of a break statement in case of a for loop. So for I in, say again range, say 100, also say 50. So if I print the value of I, it will be printing from 0 to 49, right? Range is starting from 0 and it will be continuing up to 49. Now, what if I want to break? I want to impose a break if the value of I is set. And if I have a print statement here, out of for loop, you can see up to 30 we are getting the output and then out of the for loop. Basically, this break statement has been executed and the execution is flowing, basically coming out of this for loop. So another loop controlling statement is, as I have said, continue. Now from the color, I think you have already can understand that break and continue are two keywords. So the continue statement ends the current iteration and value and jumps to the top of the loop, or the next item will be considered. Okay. Let's write another code like this. So write a program to print all the multipliers of 7 except 70 and stop printing on reaching a multiplier of 100. Now, without using this, with the knowledge up to break and continue, without the knowledge of break and continue, what we need to do? Write a program to print all the multipliers of 7. So basically, what I need to do is for I in, or we can also do a while loop as well. So let's do that using while first. Say C equals to 7. While C is less, I need to print the value of C. except there is an except statement. So if I execute this, oh, okay, so it is an infinite loop. I forgot to change the value of C. So the value of C has been changed to C plus 7, right? So you can see 7, 14, 21, and so on, including 70 are getting printed. Now, what I need to do is there is a constraint here. Print all the multiplies of 7 except 70. So what we need to do is we need to have an if statement. If C equals to 70, then I need to skip, else we need to print. Actually, if C is not equals to 70, print. You get that? Again, there are, as I have said multiple times, there are multiple ways of writing the same code. This is one way. As you can see, 70 is not getting printed here. So what I am doing is I am checking whether the value of C is 70 or not. If it is not 70, I am printing. Another way is checking whether the value of C is 70 or not. That case, I will be just passing. This is another statement, another keyword, which is basically do nothing. If I just execute, you will be getting the same output except 70. As you can see, 70 is not getting printed. Now the same thing can be done using a break and continue statement. So let's, for the time being, copy this code. Okay, so let's write that code using for loop. So for, say, I in range, say 105, because reaching multiplier of 100 greater than 100, multiplier of 7 greater than 100. So let's set this value to something to greater than 100, right? Now, if I print the value of I, it will be printing all the value from 0 to 100, right? Now, what I need to do is I need to print only those values of I which are multiplier of 7. That is, we need to check whether it is divisible by 7 or not. If it is divisible by 7, I will be printing it. In this case, 0 is an exception. I need to change that. That's why I need to put this 1 here. Now you can see the output is like this, including 70. Now I need to kind of skip this 70 here. So what I can do is I can, instead of doing this, instead of using the pass as well, I can use a continue statement here. Now this continue, if I execute this, we'll be getting the output except, sorry, extremely sorry. So not equals to 70 if it is if C equals to 70, I'll be continuing, and there is no else statement. Now if I execute, oops, sorry, extremely sorry. If I is oh, okay, change this. Now you can see, oops, still getting printed. Oh, sorry. So can someone guess what is wrong here? Why I am still getting this 70 output? Because C here is something that is set here, and the value of C has been set to something entirely different. In this case, the value, I mean, if I just print the value of C here, you'll be getting the value of C is 5, which was set earlier. I need to change this C to I. Then only it is skipped. Now, if I just remove this else statement as well, it will be printing the same output. Now, what this continue is doing is basically taking the flow from here to the next item. So let's go through this statement one by one. So why for I? So basically it is the sequence from 1 to 100. 1, 2, 3, 4. All these individual items are being considered here as I. Then the value of I is checked whether it is basically whether 7 is a factor of this value or not. If it is true, then it is checking whether the value of I is 70 or not. In case it is 70, it is taking this flow of execution from this line 4 back to line 1 and will be taking the next value, right? And if this statement is false, it will be basically coming here. Now let's change this to another thing. Say while C is say less than say greater than 0, or so I equals I is less than 0, greater than 0, and let's what will be the output? Anyone?
The infinite numbers.
Infinite number of ones, right?
Yes.
What will be the output? Come on.
Sir, 1 to 8.
1, 8, then
8, 16.
no, not 16, 15. It will be again an infinite loop.
Yes, yes.
Right? You can see it is infinite loop. So we should be starting from 0. Okay, sorry. Now if I execute, you can see these different values are getting printed. For the time being, okay. So you can see all the multipliers of 7 are getting printed, and it is infinitely many those are getting printed. Now let's start with 7. So now if I execute, you can see it is still executing, and we are getting all the multipliers of 7. Now let's look at the statement once again. Print all the multipliers of 7 except 70 and stop printing. Let's highlight on this phrase on reaching a multiplier greater than 100. Now what we can do is using how we can use a break and continue here. If I is equals to 70, we will be continuing. That is, we will be skipping that value. And that if can also be coming here. If I is greater than 100, we can break. Okay. Now if I execute, you can see, oops. Oh, sorry. So can someone guess why I am getting stopped at 63? I'm having a continue here. Can someone say why I'm getting stopped at 63 here?
So indentation problem on the if statement.
No. Look at the screen. Look at the screen carefully. What is this? What is this?
It's running still.
Yes. So the value of I has become something which is continuing to be this. Please guess why I am getting this. Because the value of I has become 70. This continue is taking the execution from here to here again. 70 is greater than 0. Again, the value of I is 70. So this statement has remaining true. And this statement, as I has become 70 and it is kept on being true, this continue is kept on being executed, and this while loop has become an infinite loop. Right? Then what we need to do is we can basically make this from 0. We can modify this. So basically we'll be starting from 0. Will be so basically 7. Is 7 equals to 70? No. Is 7 greater than 100? No. Print 7. Then the value of 7 is I is 14. But as you can see, this is always true. As I have said, we are changing the value of I from the inside of this while loop. Otherwise, it is, I mean, from just looking at this statement or these two statements, I can say that it is an infinite loop. It will be an infinite loop. But what I am doing is I'm kept on incrementing it. I'm keeping on incrementing the value of I. But here, so basically, if I execute this, you can see the desired output will be getting. So I 770, no. 7 greater than 100, no. Print 7. Then 14. Then 21. Up to say 63. Say 63 is it equals to 70? No. This is not executed. Is 63 greater than 100? No. Then this is not executed. 63 is printed. Then again the execution comes here. Now the value of I is 63. Is 63 greater or equals to 0? Yes. The flow will be entering into the while loop. Now the value of I has become 70. Is 70 equals to 70? Yes. Now this continue will be executed. The execution flow will be coming to this while loop. Now the value of I is 70. Is 70 greater or equals to 0? Yes. For the now the new value of I has become 77. Now is 77 equals to 70? No. Is 77 greater than 100? No. Then print the value of 77. And kept on after say 98. After 90 getting after printing 98, the value of I will be becoming 105. Now is 105 equals to 70? No. Is 105 greater than 100? Yes. The break statement will be executed and out of this loop will be printed. Now if I to check the value of I here, if I just print the value of I, it will be 105. Oops. You can see the value of I has become 105. Okay, so this is basically the usefulness or the application of break and continue statements. Okay. Now let's write a code which we started in the last class. Let's write a program to check whether an input integer is prime or not. A prime number is that which is divisible by divisible by 1 and itself, right? So this we have started writing. So we can see, so if the input number is 25, let's for the timing, let's have this in a separate cell. X equals to int input enter an integer. This is will be basically taking the input. Let's keep an input say 43. Now if I execute this, you can see it has kept on printing 43 for so many times, and finally it has become basically it is showing that, I mean, it kept on printing prime for so many times. Now if I give another input, say 44, if I execute this, you can see not prime, prime, not prime, prime. There's so many prints. As I have said, as we know, a number will be prime if it is divisible by 1 and itself only. So we know all the numbers are divisible by 1. Now, in order to check whether an integer is prime or not, we need to check whether the number is divisible by any of the numbers from 2 up to that number, right? In case it is say 43, we need to check whether 43 is divisible by any of the values from 2 to 42 or not, because we know that all the numbers are divisible by 1 and itself always. we need to check whether the number is divisible by any of the values from 2 up to that number or not. Okay. Now here we are seeing, so here I am checking whether it is divisible by not divisible by by those values or not, right? Now if one of the value, if the number is divisible by one of the values in this range, it will be not prime. We don't need to check whether it is divisible by the next value or not. Let's take an example. Let's say 45. Now the value of 45 will be checking whether it is divisible by 2 or not. It is not divisible by 2. Whether it is divisible by 3 or not. It is actually divisible by 3. As it is divisible by 3, we can straightforward say that it is not prime. We don't need to check whether it is divisible by 4, 5, 6, those or not. So as you can see, prime, this is being printed. I mean, if I just print the value of I, the indicator variable here as well. So you can see dividing by 2, it is showing, I mean, as it is not, 45 is not divisible by 2, it is having the it is giving the indication that it might be prime. But as soon as 3 has become, I mean, we have encountered one value which can divide the input value, we can know, we can understand that it is not prime. So we don't need to check all this, right? So what we can do is we can have a flag, which will be a variable, which is basically an indicator variable. Let's declare one prime flag. It is just a variable name. Flag is nothing, just a variable name. So prime flag, I'm initializing that with, say, true. That is, by default, I am considering the number to be prime, right? As soon as I'll be getting to one value which can divide the value, I'll be making that flag or making that value as false. And instead of printing this prime all the times, so as you can see, let's just have this, comment this out as well. If I print, if I execute this statement for, sorry, if I print, have this executed for 43, as you can see, primes are getting printed for all the values, right? But I only need to specify at the end of the execution whether it is prime or not, isn't it? So what we'll be doing is we'll be not be printing this not prime here. What I'll be doing is I'll be checking whether the prime flag is still true or not. If it is still true, I'll be printing prime, and otherwise it is actually not prime. Now this not prime is actually not needed here, because what I am doing is, now this is the complete code. What I am doing, I'm declaring one variable, initializing it with true. I mean, don't concentrate on the name of the variable. This is just a name of the variable, prime flag. It is basically, I'm naming it as a like this to indicate whether the input is prime or not. I am initializing the value to true. That is, I am considering any input value as true in the beginning. Now what I am doing is, we can skip this printing as well. Now what I am doing is, I am checking whether the input number is divisible by any of the numbers from 2 to itself, 2 up to itself or not. If it is divisible, I am changing this prime flag to false. And I don't need to check for the other values. So basically, I need to break out from this line number 5. Basically, I need to break out from this for loop. So another thing I need to do is I need to put a break statement here. Is it clear? Otherwise, I mean, without this break statement, although the checkings are not there, but still the loop is running. Still the loop is running. And the loop will be, I mean, the execution will be coming out of loop only if all the items in this range or in this sequence are traversed. That's why to force a break, we need to give this break statement or this break keyword here. Now, if I execute, you can see 43 is prime. Now, if I give another input, say 45, you can see 45 is not prime. We can make it we can also decorate it like this. You can see 45 not prime. If I give some input, say 17, 17 prime, and so on. Any question up to this? Anyone?
So, sir, basically, what prime flag function is doing?
No, prime flag is not a function. It is a variable.
Sorry, variable.
So it is basically an indicator. So this indicator, it is like, I mean, keeping a pen and paper and marking something. This is basically a paper. Oh, sorry. Oops. Sorry. Yeah. So this is basically a paper. You can consider it's basically a paper where we are keeping the note. We're basically storing the value of true here. As soon as it is becoming, as soon as we are seeing that the input value is divisible by some of the values or one of the values, that indication. So in a variable, we are storing, say 1, we are making it 0, something like this. And that thing will be, so basically in case of a actual prime number, let's consider the 17. So this, the value of I will be from 2 to 16, right?
Yes, sir.
2 is 17 divisible by 2? No.
No.
The prime flag remains true. For I value 3, again true. For I value 4, true. 5, 6, 7, 8. As no number between 2 to 16 is divisible by, is actually can divide 17, or x mod I will be becoming 0, this statement will never be getting executed, right? So the
Yes, sir.
old value of prime flag will be remaining. So the prime flag will be remaining as true. So after this while loop, after this for loop in this case, if I still get the prime flag as true, that means this statement has never been executed, which means this statement has never been true, which means the number is actually a prime number.
Mm-hmm.
And in case this statement is not true, that is, in case prime flag has become false, that means in this case, in that case, it will be getting printed, right?
Yes.
In those cases, why prime flag will be becoming false? Only if x mod I is equals to 0.
If
Which
x is
means,
divisible by I.
exactly, in that, which indicates that some values from 2 to that number, we are getting some, we are having one divisible factor.
Mm-hmm.
Got it?
Mm-hmm.
So this is
We are taking the prime flag as true, which means
right.
that the number, if divisible by the range, that is 2 to 16,
Right.
if it will be 0, then it will print the prime, or if
Right.
it is false, that is
Right.
that is
So
if
yes,
it was
exactly.
divisible.
Correct. So basically, don't get confused with this variable naming. You can have it say you can name it with anything. Say I mean, as I have said, you should be naming the variables in an indicative way. So in that case, so you can say prime indicator. So indicator, you can have a large variable naming, something like this as well. So prime indicator initially is true. If I execute, you can see for 17, it is remaining true. That's why it is printing 17 as prime number. Any question? All right. So finding prime number, there are certain there can be multiple methods of doing that. The first method, this can be considered as a zeroth method. I'm starting from 2 to itself, but we know that a better method will be from 2 to half of it, right? So we can, in that case, what we need to do is we can just this method, we can just have this range from from 2 to x by 2. In that case, it will be doing the same thing, but the traversal or the number of times the statements inside this for loop will be executed can be reduced. You get that point, right? So in this case, the for loop will be executed from 2 to the up to that value, up to that input value. In this case, it will be running from 2 to up to that value by 2. Now, I will not be saying why. I hope you will be you can understand why I am putting this +1 here, because so it's obvious. I guess you can understand why I am putting this +1 here, right? Okay, I mean, you can understand this. Okay, so this is the method 1. So method 0 is a very naive one, traverse from 2 to itself or up to itself. The method 1 is from 2 to half of it. So I hope you can understand why I'm putting this, right? Come on, okay, I'll not be saying you that.
Mm.
You
So no, I have not understood. No.
can someone say why I am putting this?
So +1,
A +1, yes.
because the range statement will exclude the quotient of the up to that quotient, so that quotient will
Yes,
be excluded.
yes. So you can also consider not taking that and can actually check. So basically up to this, basically one value less than this will be considered. So if we want to strictly follow this, we need to put this. But technically, do I have to put this? This is a question to you. This is a task for you to try. So why I am putting this +1 is just to follow this algorithm or follow this mechanism that I have put it that I have placed here from 2 to this. Why this? Because I know. So this should not be +1. Sorry, this should not be +1. Now I know that this will be, say, if this is say 11, so this value will be, this range will be from 2 to 10. This is not actually going up to 11, right? But again, I'll be asking you to test whether this +1 is applicable in this case or not. This is a task for you to try out. Just to check, just take a pen and paper. It's a simple mathematics. So you just need to check whether what is this generating and what excluding this +2 will be generating, whether it will be if we exclude this, whether it will be interfering with our output or not. Okay. So a better approach can be, what we were doing is we were going from one value, or we are kind of considering the factors from 2 up to its half. So in case the value is 36, whether, in case we are, if we are looking at all the factors of 36, so basically this statement will be executed for some factors of the input value, right? Now, if we look at the different factors of an input number, there is a mirroring order here. So if we consider 36, the factors are 1 into 36, 2 into 18, 3 into 12, 4 into 9, 16, 6 into 6, and then again it is 4 into 9, 3 into 12, 2 into 18, and 1 into 36. So if we follow this kind of mechanism, we will be going up to 18, right? But we can show that, so basically, I mean, we don't need to go beyond 6, because after that, we can, I mean, we know that it will be a repetition of factors. So the 36, for 36, the factors are basically 1, 2, 3, 4, and 6. And then it is basically a repetition. Again, 4, 3, 2, 1. Right? So instead of going from 2 to that, we can actually have, what we can have is, we can go up to the square root of that value plus 1. Again, plus 1. Now here plus 1 is actually needed. So, okay. So those of you who have some programming knowledge, you might have written some code using, say, sqrt function in C, in Java as well, in C++ as well. Here, how can we implement, or how can we specify a square root? Can someone say that? So we need to, instead of making this x by 2, we want to make it as square root of x. How to do that?
Import math and sqrt.
Okay, so this is a way, as you were saying. So import math. So I haven't discussed this yet, but the way of doing this is math.sqrt and then x. So it will be square rooting the value. But as I have said, here what I'm doing is basically I'm importing the math module and using this sqrt function which is defined in this math module. But without this, with the knowledge that we have discussed, how can we make the square root of a number? It's pretty easy. What this will do? We have said that this is basically an exponentiation. So it is basically x to the power 0.5, which is what?
Root over x. That is
Root over x, basically square root. So we can do something like this as well. So using this kind of a improvement, we can actually save some time. We can actually save some latency. Now, how can we actually test that? We can discuss that in the next class tomorrow. Today, so this is basically the method. So check the execution latency of the two methods, the method 1 and method 2. Achha, okay, let's actually do that. So basically, let's check for a given input. Say let's give one input, say 343. Whether 343 is prime or not, I want to check. Now for a smaller value, it will not be actually that much helpful. What we can do is, to check the time complexity, there is a magic command called time it. Now if I execute, it is not actually, I mean, for smaller value, it is not actually working. What we can do is basically, sorry, just $1 here. So you can see it is giving me infinite number of times. Why am I getting this? Okay, let's not confuse you. Let's just, for the time being, let's just exclude this computation. If I execute this, you can see it's being executed. But note that there is no infinite loop here, right? But still, for the x 343, it had taken around 534 nanosecond plus minus a window of 12 nanosecond per loop. Now, if I do the same thing for the second method, what is this time IT? This is called a magic command. If I again execute this, interesting. Another thing, very good, nice thing that I mean that we are actually encountering this error. So can someone say why am I getting this error? What is this?
In
This
the
actually
range you are
doing?
writing, you are not
Correct,
different
correct.
number.
This is actually a floating value. So what we need to do is we need to typecast it. Now if I execute, it is okay. Now if I just comment it out, yeah. Now, so remember the first method took 534 nanosecond plus some window. Now let's look at how, oops, it's actually taking much larger value. It's unusual. It should not be taking. So this is basically for a single value, it is actually taking that much thing. So if I again execute this, I hope I'll be getting a greater value. Oops, no. Actually, this will be helpful for a larger set of values. So I actually had planned on writing another prime numbers from 1 to n. So what I'll be doing is, so in this case, it will be actually helpful. Let's do this. Let's consider, say I have given 10,000. So I want to count how many prime numbers are between 1 to 10,000. And then I'll be basically using this method 1 and method 2. Okay. For this single values checking, it is actually giving me something that's not desirable. But let's do this for this whole thing. I'm copying the method 1. So again, my target is I want to check how many prime numbers are there in between 1 to m. So what I need to do is for I in, but I is already there is a variable. I need to give some other indicator variable. For j in, say range 1 to 1 to m, which is basically the value. M is the value, so up to m. I'm just considering m. So basically, it's up to m. And then I'll be checking this, and I'll be checking whether they are prime or not. If they are prime, I'll be also having one count, prime count, which is initialized to 0. So this variable will be containing the value of how many prime numbers I am encountering. So every time I'm encountering a prime number, what I'll be doing is I'll be just making that prime count incrementing by 1. Okay. And then finally, I'll be printing the value. Now, if I execute this, oops, prime indicator is true for J. There must be something that I'm doing wrong. Okay, if I give say for J, can someone look at it? As I'm writing so many things at a time. So prime flag is true. Prime flag is false. So here, for some reason, this statement has not becoming true. Why? This is true. This is for some reason. Oh, okay. Okay, can someone indicate the error here? I'm still using X here. I should be replacing it with J, right? So here, basically, the outer for loop is generating all the numbers from 1 to 10,000, before 10,000. And I'm checking whether that value is prime or not. So I need to change this to this as well. Now, if I execute this, you can see there are 1230. Now, if I do the same thing, this is the first method. And if I do the same thing using the second method, that is J star star 0.5, and then putting there inside an int, you can see must be doing something wrong. Okay. So I should be making, so this is 10,000. This is, you can see. So here I am making something. Oops. I'm skipping some values for some reason somewhere. I'm unable to locate that for the time being. This should be +1. And this should be +1 definitely. And for the first method, okay. So first method, we should be doing this as well. Okay. So again, why +1 should be there? It's up to you to, to just check. It is pretty easy to understand. So you can see there are 1230 prime numbers in between 1 to 10,000. Now, if I want to check the number of times it is actually generating, it is actually getting executed, or the time it is taking, $, as I have said, uncomment it, just compute it. It is executing. So time it is a special command which can compute the execution time after running 10,000 times, actually 1,000,000 times the same thing, and running 10 loops for each execution and computing the average. Now, if I do the same thing here, I hope it will be giving us less time. You can see the earlier case, it was taking 150. It is a significant drop, isn't it? So the method 2, in which case we were going from 2 to half of the input number. On an average, one prime number computation was taking 153 microsecond plus some window. In this case, it is taking 9 microsecond when we were changing the ending limit. Earlier, it was half of it. Now we are replacing it with the square root of the number. So it is now from 153 microsecond, it is now 9 microsecond plus some nanoseconds. Okay. So this is the way to compute or to check the time complexity, or to actually check how much time a program execution is taking. Okay, so there is a third method using which we can also do that. I will be sharing this slide. I will be asking you to try that out at your end. So basically, you need to change this, either of this implementation, and you can do this. So why are we so much interested on prime numbers? So they are very much useful in so many applications such as cryptography. Cryptography is a subdomain of computer science and mathematics, which is basically responsible for all these security purposes. It is also very much useful in random number generation, and it is the prime numbers are also very useful in quantum computing. So that's why we were kind of so much interested about getting a prime number. So the thing we will be ending our discussion with, today's discussion with, is this program. Write a program to take a year as input from the user and check whether the year is a leap year or not. But wait a second. You might be wondering that we have already written that code, right? Let's check this, the same thing. We have already written the code in the last class. Yes, this was the code. It was not the efficient one. There are so many unnecessary prints were there. This was the code, right, that we have written. Now, if so, here we need to take this year as input, right? Year equals to input, enter the year. Oops. Say 2004. And if I execute, it is giving me a leap year. Okay. Is it okay, right? So we have given, we have kind of written this code. What if I enter a negative year? What if I enter a value, say minus 2004? For some, I mean, mistakenly I had written minus 2004. This is a very important concept. Please concentrate on this. This is a very important concept. If I execute this, it is giving me some input. I mean, it is giving me a leap year in this case. But the thing is, I mean, these conditions are getting just satisfied, but this is an erroneous statement, right? In case I give something random, in that case as well, it will be giving us some output. But from our perspective about the year, we know that a year cannot be negative. This is an erroneous statement, right? So how to kind of give, how to kind of address this? How to address this kind of negative value, or in this case, taking this negative year as. So this is the agenda of the last agenda that we will be discussing in this class. So this is a very important concept. This is called conditional infinite loop. So we will be making an infinite loop which is conditioned. The condition in this case will be until and unless you are entering one positive year or positive integer, you will be needing to continue giving the inputs, right? So I will be giving, so this, let's consider this we have already written. While year is less than or equals to 0, because 0 year is also, let's consider it's only less than 0, only negative. Print error in the input, please enter again, and then again this. Now if I give, say minus 123, so if I give any value, any negative value, it will be basically an infinite loop. It is basically an infinite loop conditioned on this input. Now if I give, say 2004, you can see the execution has stopped. So the execution has stopped based on some input. So this is a conditional infinite loop. It is an infinite loop based on some condition. If the condition is met, it will be kept, it will be keeping on executing. Otherwise, it can actually break out of this while loop or this infinite loop. Now, Now, as you can see, there are these two statements are same. So it is again one task for you guys.
Sir, can you explain again, like why
Yeah.
is it
Oh,
not
acha.
printing the print statement in infinite times? Can you explain
No,
it again?
no. So basically, if I exclude this, sorry. So this is the cell. So if I exclude this, right? So let's consider you have only these three lines. You are taking an input and then you are checking whether it is less than 0 or not, whether it is negative or not, and then you are printing error in input. Please enter again. In that case, if I give an error, if I give some positive value, it is okay. If I give some negative value, then it will be an infinite loop, right? Right? It is an infinite loop, as you can see. Now, what I'm doing is I'm putting one statement here as well. Say minus say 125. So here will be minus 125 after this. So here will be minus 125. So basically this statement will be printed. So let's just execute it. So this statement is printed here, and the next statement is executed again. The next statement in this case, which is again taking an input. So there is a provision that we can come out of this infinite loop if we enter one positive. Already encountered this kind of scenario in while filling up some online forms. In those forms, you might have seen that some fields are mandatory. Without filling those mandatory fields, you will not be able to proceed. Right? If you continue, if you continue if you continue skipping that mandatory field or giving some erroneous value, if say the text box which is expecting one date, if you are giving something not a date, or in case you are making one login information, you are making one login in some web server, and if the password has some predefined criteria to be matched in order to make one profile, and if you are not meeting that criteria, it will be continue on taking your, it will be giving you error message, and you need to continue giving the, setting the password until and unless you are setting it in the right way. It will be continue doing that, right? It will be continue giving you the error message. This is a similar scenario. This is an infinite loop conditioned on this statement, conditioned on the input given by the user. Got it? Now, if I give a negative value, again, it will be an infinite loop. But if I give some positive value, it will be okay.
Yes, sir, I got it.
So this is called conditional infinite loop. Okay, so that's it for today. So we discussed up to this infinite loop. Nested loop, we did not have the time to discuss. We can discuss that tomorrow. Here are two exercises for you to try. Write a program to find numbers that are divisible by 7 and multiple of 5 between 500 and 1500. And the second statement is, I have already written, you need to write a program to take a positive integer as input and print the cth value of the Fibonacci sequence. The Fibonacci sequence is basically 0 and 1, the first two values of Fibonacci sequence, and all the rest of the values will be the summation of the previous two values. So 0, 1 is the initial two values. Then this will be the summation of 0 and 1, which is 1. This will be the summation of the previous two values. This will be the value sum of previous two values, and so on. So the first two terms are 0 and 1. All other terms are obtained by adding the preceding two terms, and so on. So basically, you need to write a program to do that. Okay. So thanks a lot.